Assalamualaikum and very good day. Before we start with the new chapter integration, let's have a look on the requirements needed for this chapter. You can have a look on these notes on your topical, your revision pack. So first we need to understand the integration as the reverse process of differentiation, and we need to know how to integrate sum of terms in powers of x, including 1 over x and 1 over ax plus b. And then we need to know how to integrate the functions in the form of ax of n for any rational sin ax plus b cos ax plus b e to the power of ax plus b, and also all this down here. So you need to know what you need to study in this chapter. I'm going to talk about 7 to me major subtopic for this chapter. Okay, we will start with the first things that we are going to have a look is the integration as the inverse of differentiation. So what does it mean by integration as the inverse of differentiation? Suppose that we have a function y. Function of y. When we differentiate y, we will get dy over dx. But when we integrate dy over dx, we will get y. A similar concept for second order derivatives. If we differentiate dy over dx, we will get d squared y over dx squared, which is the second order derivatives, which means that if we integrate d squared y over dx squared, we will get dy over dx. Somehow the symbol should look like this. To get y, we must integrate dy over dx with respect to x. That should be enough. If we integrate d squared y over dx squared, we should get dy over dx. The symbol bigger here means integration. And I also want to talk about indefinite integral. Say we have y equals to 2x squared. Then dy over dx is equals to 4x. Say we have one more example, y equals to 2x squared plus 5. Hence dy over dx is still 4x. If we have y equals to 2x squared minus 1 over 2, still the value of dy over dx will equals to 4x squared. So no matter what's the coefficient behind here, still when we differentiate this function, we will get the same result. which means that in general, if we differentiate 2x squared, 2x to the power of 2, we will get 4x, which means that if we integrate 4x with respect to x, we should get 2x squared plus c. Because c could be 0, c could be plus 5, c could be negative 1 over 2. We don't know the value of c, but c can be anything. Okay, let me repeat again. In general, if we have 4x, so we integrate 4x with respect to x, we should get 2x squared plus with c. So when we have plus c behind here, it means that we refer to indefinite integral. As we go along with the lesson, you will understand why we must put plus c there. Okay, so we've done with the first subtopic. Now we are going to have a look at the integration of the form ax to the power of n. Integration of the form ax to the power of n. Before we start, let's have a look at a few important formulas. Integration of a constant a will result to ax plus c. Example, if we integrate a constant 2, say, so the result should be 2x plus with c. Another important note is that if we have integration of a constant multiplies with a certain function with respect to x, we can actually bring the constant out there. So which means that this is just equals to a multiply with the integration of the function fx with respect to x. For example, if I want to integrate 2x squared with respect to x, this is equals to, I can bring 2 outside because 2 is just a constant. This is equals to 2 times with integration of x squared with respect to x. So we are going to have a look on how to integrate this type of function, but you need to remember that a constant we can bring outside, and also integration of a constant will result in ax plus c. Let me shrink this and put this on the side. So let's have a look at the integration of ax to the power of n. There's a formula that you need to remember. Integration of ax to the power of n with respect to x is equals to ax to the power of n plus 1 over n plus 1 plus with c. Okay, let's have a look at a few examples. Integrate x squared with respect to x So by this formula, we should have x squared plus 1 over 2 plus 1 plus c, which equals to x to the power of 3 over 3 plus with c. Second example. Let's try integration of 2x to the power of 3 plus 5x to the power of 2 plus with 3 with respect to x. So when we have plus or minus, we have to look individually. So first we integrate 2x to the power of 3 will result on, by this formula, we should get 2x to the power of 3 plus 1 over 3 plus 1 plus with 5x to the power of 2 plus 1 over 2 plus 1, and integration of a constant, we should get 3x and plus c. Simplify everything, should get 2x to the power of 4 over 4 plus with 5x to the power of 3 over 3 plus with 3x plus c. You can simplify the first one, so we should get x over 4 over 2, x to the power of 4 over 2 plus with 5 over 3x to the power of 3 plus with 3x plus c. This is your final result. More examples. Maybe let's have a look at more examples. One or two more. Integration of 2x squared minus 5 with respect to x is equals to 2x to the power of 2 plus 1 over 2 plus 1 minus integration of a constant 5x, then you add plus c because this is indefinite integral without boundaries. Simplify everything, you should get 2x to the power of 3 over 3 minus 5x plus c. Just to check the answer, let's try to differentiate this function. So we will try to differentiate 2 over 3x to the power of 3 minus 5x plus c. So if we differentiate here, remember how to differentiate? You have to bring 3 at the front times with 2 over 3 times with x to the power of 3 minus 1 minus 5 plus a 0. So we should get 2x to the power of 4 minus 5, which is consistent to our question. Means that integrate 2x to the power of 2 here. Okay, so it means that if we integrate this function, we will get this function. But when we differentiate this function, we should get that function. So when we differentiate this function, we should get that function. One thing about integration, in integration we do not have a product rule, quotient rule, or composite rule. If we want to integrate, we have to expand and simplify, then only we integrate. Okay, let's have a look at more examples on how to do basic integration. For example, integrate negative 10 with respect to x. So again, negative 10 is a constant, so the result should be negative 10x plus c. And how about integration of 3 minus 4 over x squared plus 6 over x to the power of 3 with respect to x. Again, in this case, we have to treat each term individually. Before we do that, remember to bring the denominator to become the denominator. So this is just equals to integration of 3 minus 4x to the power of negative 2 plus with 6x to the power of negative 3 with respect to x. So we integrate individually. So when we have a constant, we should get 3x. The next one, negative 4x, negative 2 plus 1 over negative 2 plus 1, and plus 6x to the power of 3 plus 1 over negative 3 plus 1 plus with c. Don't forget your c. So now we simplify everything. 3x minus 4x to the power of negative 1 over negative 1 plus with 6x to the power of negative 2 over negative 2 plus c. Which is equals to 3x. Negative divided by negative, we should get positive. 4x to the power of negative 1. Positive divided by negative, we should get negative. 6 divided by 2, 3. X power of negative 2 plus c. And we should make this to look better. We will get 3x plus 4 over x minus 3 over x squared plus c. That is your final result. Let's have a look at a slightly more complicated example. Let's try maybe integration of 1 plus 2 over x multiply with 1 minus 2 over x dx. Again, for integration, we do not have composite rule, product rule. No, we do not have. You need to expand, simplify, then only you integrate. So in this case, expand this first. If you notice, the pattern is a plus b, a minus b. So if we expand, remember, if we expand a plus b multiply with a minus b, we should get a squared minus b squared, which means that we should get integration of a is, in this case, 1 squared minus with 2 over x squared with respect to x. So integration of 1 minus 4 over x squared with respect to x, which equals to integration of 1 minus 4x to the power of negative 2 with respect to x. And remember, if we want to integrate ax to the power of n with respect to x is equals to ax to the power of n plus 1 over n plus 1 plus c. Apply this formula here. Okay, again, when we have two terms, the first term and the second term, do integration individually on each term. So it means that the integration of 1 will equals to x or 1x minus with integration of this part, use this formula. It will become 4x to the power of negative 2 plus 1 over negative 2 plus 1, and again indefinite integral must put plus c. Simplify everything. If we have 1 in front of x, normally we do not write the 1, we just write as an x, minus with 4x to the power of negative 1 over negative 1 plus c. Negative times with negative, divide by negative, we should get positive. 4x to the power of negative 1 plus c. So final answer is x plus with 4 over x plus with c. Maybe we need more example. Slightly complicated. Let's see if I can fit everything in here. Let's try something harder. Maybe integration of 3x to the power of 3 minus 3x to the power of 2 plus 4 with divided by x squared with respect to x. Again, look at each term individually. This is just equals to integration of 3x to the power of 3 over x squared minus 3x to the power of 2 over x squared plus with 4 over x squared with respect to x. So you can simplify. X squared here becomes x squared, done. So rewrite everything. Integration of 3x minus 3 plus with 4x to the power of negative 2 with respect to x. So it will become 3x to the power of 1 plus 1 over 1 plus 1 minus with 3x plus with 4x to the power of negative 2 plus 1 over negative 2 plus 1 plus with c. Simplify everything. We should get 3x squared over 2 minus 3x plus with 4x to the power of negative 1 over negative 1 plus c. You can simplify this plus divided by negative, you should get negative. So the answer is 3 over 2x squared minus 3x minus 4 over x plus with c. Now we have done integration of ax to the power of n. So after this, in the next video, we will going to cover the integration by substitution. I hope you enjoyed today's video, and I'll see you soon. Bye bye.